Okay, welcome to 8.2. This is a section on graphing translations and reflections. So it's important to notice that translation and reflections are both examples of something in mathematics that we call transformations. And just like the name sounds like, we're transforming a shape, a geometric shape, a triangle, a square, a parallelogram. We're going to change it in some way. So a translation involves moving a shape in a straight line. And that straight line can be either up and down or left and right, but basically we're just shifting it over in one direction or another. A reflection occurs when the shape is reflected across a mirror line. So we make an exact copy that is a reflection. The original object in both of these cases, we call the original object, we'll just call it the shape, okay, whatever we started with. And the final object is called the image. So that's the thing that we end up with, the final product. So just take a look here. Two different translations we're looking at. So on the left, what translation is shown below? One thing I want you to notice is we've got two shapes. So I've got a triangle here, ABC, and then I've got another triangle here. It's also ABC, but you'll notice there's these funny little tick marks beside the ABC. So that little tick mark means that it's that's what we changed it to. So basically, this is my shape, and this second one here, this is my image. So I started over here and I moved over there. That little tick mark, by the way, is just called prime. So this is A, whereas this one here would be called A prime. Okay, so to figure out what's happened when we moved, we can literally just count boxes. If we started here, this point A was here, and we moved over to this point A prime. So we moved 1, 2, 3, 4, 5, 6 boxes over to the left, and 1, 2 boxes down. So the translation we had was 6 spaces to the right, and two spaces down. So as it turns out, it doesn't matter which of our points we started with. We can start with any point to find this. So imagine we start at C and we look at C prime. Again, I could go 1, 2, 3, 4, 5, 6 spaces over to the right and 1, 2 spaces down. And I can do the same thing with B. It doesn't really matter. I should end up with the same result because our shape hasn't changed. Okay, let's look at this second question. It's asking, where is the line that created this reflection? The first thing to notice is that our original shape is over here on the left, and the final shape, our image, I should say, that we end up with is on the right. So this is my shape, or my original object, and this is my image. I know this because when I look at this image, all of the letters have that little prime beside it. So I know that in that case, each of those represents the changed or transformed shape. Okay, so they're asking us where is the line that created this reflection. So you may have a sense that the line is actually this one right through the middle, and you'd be absolutely correct. The way to find the line, or the thing to notice about the line, is that it is the same distance between So the thing to notice about these lines is that it's the same distance from, say, E to the mirror line as it is from the mirror line to E prime. So it's 2 boxes between E and the mirror. It's also 2 boxes between E prime and the mirror. You'll notice the same thing with G. 1, 2, 3, 4 boxes there, and 1, 2, 3, 4 boxes to G prime. So when we create a reflection, as long as each of our points is the same distance on the other side of the mirror, then we can create our image based on that. Okay, let's take a look at how to do this in a couple of examples. So we've got this triangle here, ABC, and we need to translate it 6 spaces to the left and 4 spaces down. So essentially what we can do is we can take each of our points, I'll just start with A, for example, and I can move it 6 spaces left and then 4 spaces down. So I'm just going to count over 1, 2, 3, 4, 5, 6 spaces to the left, and 1, 2, 3, 4 spaces down. So this would be my new point that I moved to, and I would call this A prime, or A with that little dash beside it, apostrophe. I can do the same thing with B, and I'll just count this up. You don't have to count out the boxes, you can just count it out. So 1, 2, 3, 4, 5, 6 boxes over to the left, and 1, 2, 3, 4 boxes down to find B prime. And for C prime, same thing. 1, 2, 3, 4, 5, 6 boxes to the left. 1, 2, 3, 4 boxes down. And there is C prime. Now all I have to do to find my image is connect my points. Okay, and I've got my new image. So this is my original shape. And here's the translated image. Okay, for reflections, remember the key with reflections is that our final image has to, the points have to be the same distance from the reflection line. So in this case, we're looking for reflect the triangle over the x-axis. So I'm going to use my x-axis as the mirror line. So I can just pretend that this x-axis here is my mirror. Okay, this whole line across. So, for example, if this is the point E and it is 1, 2, 3 spaces above the x-axis, then the reflected point E would be 1, 2, 3 spaces below the x-axis. And so here would be E prime. Point F is 1, 2, 3, 4 points above. So I go 1, 2, 3, 4 points below the x-axis, and there's my F prime. And D is 1, 2, 3, 4, 5, 6, 7, 8 boxes above. So 1, 2, 3, 4, 5, 6, 7, 8 boxes below. And there's D prime. And now I just need to connect my dots. And here's my shape. And there's my image. All right, that's it for 8.2.